Hi, in this video we are going to learn about indices. Now the word indices is plural for the word index. So what is an index? An index is a small floating number that appears after a number or a letter. So if you have a number 2 and there's a number floating on top, then that number floating on top is what we refer to as an index. You might find some people referring to this as a power or an exponent. Now, whereas the number 2 is referred to as the base. So 2 here is the base. So if you have a number, or rather a letter raised to a power, say 4, then A here is referred to as the base, while 4 is called the index or the power or the exponent. Now, let's look at some rules of indices. So let's look at the first rule, and this we are going to refer to it as the multiplication rule. So the multiplication rule says that a raised to power m multiplied by a raised to power n is the same as a raised to power m plus n. Now, how do we demonstrate this rule? Suppose we have a squared multiplied by a cubed, and we want to simplify that. Then we will take a multiplied by itself twice and multiply by a multiplied by itself 3 times. Now this is the same as multiplying a by itself 5 times, which is the same as a raised to power 5. Now if you look at the result we have here, this is as good as taking the base a and adding the powers 2 and 3. So that demonstrates the first law of indices, which we are calling the multiplicative, or rather the multiplication rule. Number 2, we have a power m divided by a power n is the same as a raised to power m minus n. Now, how do we demonstrate this? Suppose we have a raised to power 6 and we are dividing this by a raised to power 3. Now, this is the same as a multiplied by itself 6 times, and you are dividing this by a multiplied by itself 3 times. So if you divide a by a, you will find that you'll end up with a times a, which is actually the same as a cubed. And the a cubed you are left with could as well have been obtained by simply subtracting the powers that we had initially. That is, taking 3 and subtracting it from 6. So this demonstrates the division rule of indices, which says that a power m divided by a power n is the same as a raised to power m minus n. So this demonstrates the division rule of indices. Now let's look at the third rule, which says a raised power m raised power n is the same as a raised power m times n. Now, this is referred to as the power rule. So let's see how we can demonstrate this. Suppose you have a squared, then we have cubed outside. A squared, a raised to power 2, and then everything raised to power 3. How would you write this? This is the same as taking a squared and multiplying it by itself 3 times, which is actually the same as a times a times a times a times a times a, which is actually the same as a. Now, using the first rule of indices, we will need to add all the powers here. We need to add all the powers. So this will become a raised to power 6. And this demonstrates the power rule that we've looked at. So this demonstrates the power rule. Now, let's look at the fourth rule. The fourth rule says that a raised to power 0 is equals to 1. Now, this is called the zero power rule. How can we demonstrate the zero power rule? Now, suppose we have a raised to power 5 divided by a raised to power 5. We know from the second law of indices, or from the division rule of indices, this is the same as a raised to power 5 minus 5, which is the same as a raised to power 0. However, a raised to power 5 divided by a raised to power 5 is actually the same as taking a raised to power 5 and dividing by a raised to power 5, which is the same as a times a times a times a times a, and dividing by a times a times a times a times a. So if you cancel the corresponding a's, you'll realize you will end up with a 1. So since these two expressions mean the same thing, you can therefore say confidently that when you raise 0 to any base, then the result will be 1. Now, so that's all for the zeroth power rule, for the zero power rule. Now, number 5, let's look at the negative index rule. Now, how do you demonstrate the negative index rule? Now, suppose we have a raised to power minus 3. We know we can write a raised to power minus 3 as a raised to power 0 minus 3. And from the division rule of indices, this is the same as a raised to power 0 divided by a raised to power 3, which is the same as a raised to power 0 divided by a times a times a. Now, a raised to power 0 we know is 1. A times a we know is a cubed. So this implies that a raised to power minus 3 is actually the same as the reciprocal of a cubed. So that demonstrates the negative index rule. Now, let's look at the next rule, which is called the fractional index rule. What does it say? The fractional index rule says that a raised to power m over n is the same as nth root of a raised to power m. Now, how do we demonstrate this? Now, let's try to demonstrate this what is a raised to the power half multiplied by a raised to the power half? This is the same as a half raised to the power 2 using the power rule, which is the same as a. So if a raised to the power half multiplied by a raised to the power half is a, it means a raised to the power half is actually the square root of a. Now another example, a third times a raised to the power third times a raised to the power third is a raised to the power third cubed, courtesy of the power rule, which is the same as a. This means that a raised to the power third is actually the cube root of a. Okay. Now, if we take a raised to the power third and square it using the power rule, this is the same as taking the cube root of a and squaring it. Now that demonstrates the fractional index rule of indices. Now notice that a raised to the power third squared, which we are saying is the same as cube root of a squared, can also be written as a squared raised to the power third, because multiplication is commutative, and therefore we can rewrite this as cube root of a squared. So this means that a raised to the power third squared is the same as a squared raised to the power third, and it is the same as cube root of a squared, and it can also be written as cube root of a squared, everything squared. So you can express this in any of these forms and you will still be correct. So that proves, or rather demonstrates, the fractional index rule. Now let's look at the seventh rule of indices, and this rule can be written in two ways. We have a times b raised to the power m is the same as a raised to the power m multiplied by b raised to the power m. What this means is that if you have 2 times 3 and this is raised to the power 4, then this is the same as taking 2 and raising it to the power 4 and multiplying by 3 raised to the power 4. They'll give the same result. Now the second one, the second part is a over b raised to the power m is the same as a raised to the power m divided by b raised to the power m. Now an example of this is if you have, say, 5 over 4 squared, then you can write this as 5 squared over 4 squared. Or if you want to simplify, that is the same as 25 over 16. So what this rule says is that if you multiply any two numbers and raise the result to a certain power, then that power can be distributed over multiplication. Or if you divide any two numbers or any two terms and you raise the result to a given power, then that power can be distributed over division. Now let's look at the eighth rule of indices. What does the eighth rule of indices say? It says that if a raised to the power m is the same as a raised to the power n, then this can only hold if m and n are equal. For example, suppose 2 raised to the power 3x plus 1 is the same as 2 raised to the power 4y minus 5. Then this can only be true if 3x plus 1 is the same as 4y minus 5. So that summarizes our rules of indices. So what we are going to do next is we want to look at how we can solve problems that will make use of the rule of indices that we have discussed. Now, let's look at these examples that make use of the rules of indices that we've discussed. So let's look at the solution to the first example. We have 3 raised to the power 2 over 5 x a half multiplied by 3 raised to the power 8 over 5 x raised to the power 3 over 2. Now, how do we solve this? Now, we can see clearly that this involves multiplication, meaning that if we are able to group the like terms together, we can actually make use of multiplication law of indices to simplify our problem. So we can rewrite this as 3 raised to the power 2 over 5 times 3 raised to the power 8 over 5 multiplied by x a half times x raised to the power 3 over 2. Now, using the first law of indices, we can, which says that am multiplied by an is am plus n. We can write this as 3 raised to the power 2 over 5 plus 8 over 5, and when you are done, we do the same on this side, x raised to a half plus 3 over 2. Now, 2/5 plus 8/5 is 10/5, which is 2, and half plus 3/2 is 4/2, which is again 2. So this will be multiplied by x squared. So our answer will become 9x squared. So the solution to problem number 1 will be 9x squared. Now let's look at problem number 2, and the problem number 2 says 625 raised to the power half y raised to the power 6 divided by 5y squared. So we are supposed to simplify that. Now, how do we do this? Since we have 5 on this side and we have 625 here, we can try to rewrite the expression so that it is in terms of base 5. So we can write 625 as 5 raised to the power 4. And then remember, we still have our half outside, and y, of course, is power 6 raised to power 6. And remember, because it is division, we can divide this by 5y squared. Now this simplifies to using the power rule that says a power mn is amn. We can simplify that to 5 squared by multiplying 4 by half, and then we have y power 6 over 5 y power 2. Now this can be rewritten as 5 squared. Now using the negative exponent rule, or the negative index rule that says a raised to the power minus n is 1 over an, we can bring 5 and y squared upstairs so that we have 5 raised to the power minus 1 and y power 6, and again if you take y squared upstairs, we'll have y raised to the power minus 2, so that now using the first law of indices, this can be written as 5 squared plus minus 1 multiplied by y 6 plus minus 2, which is the same as 5y raised to power 6 plus minus 2, which is power 4. And that is your solution. In number 3, we have 6 raised to power third times z raised to power 2 thirds. Everything is raised to power 6. Now, looking at this, you will realize that we may have to make use of these relations here, since two different terms are raised to the same power. And as we said earlier, when we have such a situation, the power is distributed over multiplication. So if you do that, then you'll have 6 raised to power third raised to power 6 multiplied by z raised to power 2 over 3 raised to power 6. Now, if you simplify each of these terms, then you'll have 6 squared. Now, 2 thirds of 6 is 4, so this will be z raised to power 4. So the answer becomes that 6 z raised to power 4. Now, let's look at number 4. We have 64 raised to power third m cubed n raised to power half, everything divided by 8 raised to power third times n raised to power 4 and a half. Now, how do we go about this? Now, you realize that we could rewrite 64 so that it has a base of 8. And since we have m cubed and m here, we could take m downstairs, upstairs, using the negative index rule, and do the same, take n raised to power half downstairs, using the negative index rule, because the power of n above is less than the power of n below. So we could write this as 8 squared raised to power third multiplied by m cubed times m raised to power minus 1, in which case I have taken m upstairs using the negative index rule. And then downstairs, we are going to have 8 raised to power third times n raised to power 4 and a half times n raised to power minus a half. Now, if we do that, we are going to have 8 2 thirds. I have simplified 8 squared everything raised to power third using the power rule. And then I want to take 8 a third upstairs as well. So we'll have 8 minus a third multiplied by m cubed m minus 1 divided by n 4 and a half times n minus a half. Now, using the first law of indices, this is the same as 8 2 thirds minus a third, because I'm adding 2 thirds to minus 1 third, multiplied by m 3 plus minus 1, and downstairs we have n raised to power 4 and a half plus minus a half, which simplifies to 8 times a third raised to power third m squared over n power 4. So, and 8 raised to power third, if you wish, you can write that as cube root of 8, which is 2, or you could write 8 as 2 cubed raised to power third m squared over n power 4 set. So in both cases, you will end up with 2m squared over n power 4 as your solution. So I want you to attempt the following problems, solve the following problems, and if you do them correctly, then you should obtain the following solutions. I hope that helps.